March, week 2, math, 3rd grade, lesson 1. Applying properties of operations. Who remembers any of the properties?
Oh.
Silas.
The commutative property.
Distributive. Distributive. Yeah, the last one's hard. Associative. Okay.
I knew it had something to do with it.
Commutative is easy.
Yeah.
4 times 3 is the same as 3 times 4.
Yeah.
Or 2 plus 1 is the same as 1 plus 2. You're just switching stuff.
Yeah.
Associative is you have 3 things and 2 of them are in parentheses. That means those 2 are like right next to each other, and then the 3rd guy is still their friend, but maybe he like went to see Miss Jeannie or something. Get it? It's who's associating closer.
Or he went to McDonald's.
Or went to McDonald's. All right. And then the distributive is the hardest one to remember. It's the one where you've got like, maybe you have 9 of something, 9 boxes of milk. And the truck that has that milk drops 5 of them off at the city market in Delta and only 4 off in Hotchkiss. That's distributing something.
Yep.
Okay? Means it's still the same amount, it's just going to 2 different places. Okay. So, show that the product of 3 times 4 is the same as 4 times 3. Boom, boom, done. All set for that front page?
Yeah.
Very easy. Okay. Next. Using these little tables, show that the product of 3 times 4 is the same as the product of 4 times 3. This time they want us to use the multiplication table and find 3 times 4. So put your finger here and here and bring them together and draw a circle around the 12.
It's written in bold letters.
Well, the add-ends are written in bold, yes.
Yeah.
And then the sums are not in bold. Now go, oh, sorry, it's times. The factors, listen to me, are bold. And the products are not bold. Now go here and do 4 times 3. Bring your fingers together. It's 12 again.
Yeah.
It's just in a different place. And it says, look at the factors and the products. The factors are the same, but they are in a different order. The products are the same. 3 times 4 and 4 times 3 have the same product, which is 12. Now here it says, what other multiplication fact uses the same numbers as 2 times 3 is 6?
Or 3 times 2 is 6.
3 times 2 is 6. Next time, put your hand up. Griffin has a flat hand up, but you're right. 3 times 2
6 times 1 is
is 6. Yeah, but they wanted it to use the exact same numbers. Gideon, look, the question was, what other multiplication fact uses the same numbers as 2 times 3 is 6? So the numbers are 2, 3, and 6. Thank you, Ruben. So we don't want to be saying 6 times 1 is 6 because 1 would be a new number. And they want us to stick with these 3 numbers.
Yeah.
So Ruben, we're just going to go straight to page 40. Lindsay writes the equation 5 times 6 is 30. Use the commutative property of multiplication to write another equation. Well, that's easy. What would it be?
6 times 5.
Yes. Right.
And we don't
They
need
already
any of that.
have it.
Yeah.
Now they're wanting you to check with an array. So here they have 1, 2, 3, 4, 5 groups of 6, and here they have 1, 2, 3, 4, 5, 6 groups of 5. They do both make 30 if you count the dots.
6 times 6.
Wait, we're not going to.
So we're not going to do that. Here, though, it says explain how the commutative property can help you with multiplication facts. All right, what would be easier to figure out? 5 groups of 7 or 7 fives?
7 5.
You all picked 7 fives. Okay, why?
Because
it's smaller and easier.
Why is it easier? Which one's easier to skip count?
5
Your sevens or your
5
fives?
groups of 7.
Fives are much easier to skip count. So sometimes flipping, come on, right. Here's your root word, flip. Double the P before you add in. Flipping the factors can make skip counting what? Easier. Okay, you've got to write that. So, it doesn't always. Gideon. Oh. You all right? Got it? Everybody got it?
What we're lasting for changes. This is how I like to do things.
So far, it's pretty easy.
Wait.
Page 41. Use the associative property of multiplication to find the product of 2 times 3 times 4. So they want you to group the 2 and the 3 together first, and it's going to make 6. And so now we have 6 times 4, which is 24. Okay. Here they're wanting you to use models to check. So they made 2 rows of 3, and then grouped them into 4 groups. So here we have 1, 2, 3 rows of 2, 1, 2, 3 rows of 2, and so on. And they're doing that 4 times, and it makes 24. Now they want you to try 2 times 3 times 4 again, but grouping the factors in a different way.
What times 2 times
3 and 4.
Keep the 3 and the 4 together. Okay, so let's put parentheses around the 3 and the 4.
Aren't we supposed to write it down here?
We're going to, but first let's just be naughty and use theirs, okay, Luden? So 2 times 3 times 4 is the same as 2 times what?
2 times 4.
No,
2
you-
times 3 times 4.
Yeah, which is, we're now going to solve what's in the parentheses, because you know the rule, parentheses first, right? These excuses.
My dear Aunt Sally.
Here it's out. So what do we write for that?
12.
Yes. Okay, so we're keeping the 2 times, and then we're solving that, and that's 12. So this is the second way we're writing it.
I think 12 times 2 would be much easier.
Yeah, but we're just, so now 2 times 12, we all know that.
24.
What is it? It is 24. Okay. So they asked, is the product the same?
Yes.
No. Yes.
Yes, right? Because up here, they did it by doing 6 times 4, and here, we did it by doing 2 times 12. It made 24. So we need to write yes. Product is the same. Okay, it says example C, use the distributive property to find the product of 6 times 8. Honestly, guys, would you really use the distributive product for that?
No.
No, 8s are pretty easy. You wouldn't. You would just count your 8s. 8, 16, 24, 32, 40, 48.
What is look up there?
They're asking us to, so we do need to do it. And why do you think they're asking us to do it? It's because later, you're going to be doing a way bigger problem, and you will want to split it. And so they're letting you practice with easy numbers. So they're splitting the 8 into 5 and 3, which is cool. 5s are really easy. So they're going 6 times 8 is the same as 6 times
5 times 5 plus 3.
5 plus 3. And did you hear how Griffin stopped himself from saying 5 times 3? That was terrific. It is not 5 times 3, correct? It is 5 plus 3.
Then you'd
Because
be adding.
8 is not the same as 5 times 3, but it is the same as 5 plus 3. So that was cool how you checked yourself. So multiply each add-in by 6. So you're going to go 6 times 5 plus 3 is 6 times 5 plus 6 times 3. So you're going to solve for the parentheses. So that's the same as 30 for 6 times 5 and 18 for 6 times 3, which does come to 48. And they're showing it with an array. They're showing it with an array. There's your 6 5s. There's your 6 3s. If you add up all the dots, which we're not going to bother with, it's going to make 48. Down here, it says use the distributive property to find the product of 9 times 8.
But it's 72. Everybody knows that.
I know. We know it's 72, but what do we want to split the 8 into?
5 and 3.
5 and 3? 4 and 4?
I'm do 4 and 4.
4 and 4?
I get 4.
Okay.
484.
So we're going to write 9 times parentheses 4 plus 4. Okay, what's the next thing?
First we do the parentheses.
Good, so we're going to put equals parentheses 9 times 4 for the first 4. Now put a plus sign. You have to close that parentheses. Okay. Then put a plus sign. And now we're going to do 9 times the other 4. So open new parentheses.
So many parentheses.
Yeah. And put 9 times 4 again. And then who can solve? This.
72.
Silas?
9, 18, 27, 36.
So 36 for this one. Then keep your plus sign. And then we don't need to solve that one because it's the same. Just write 36 again.
I'll do it again. And then 36 equals 36.
Now we could write an algorithm, but honestly, adding 36 and 36 isn't that hard. 30 plus 30 is 60. 6 plus 6 is 12. 60 plus 12 is 72. Yep. Okay.
You can just count by your mind. It's way easy.
I know. I
They're making
totally
you do too
agree.
much work.
But remember, they're letting you practice with fairly easy numbers so that you can do it later on with really tough numbers. And of course, as you guys can imagine, it's a great strategy to be able to split really tough numbers up. All right? It's a fabulous math strategy.
Yep.
Let's go to page 43.
Ah.
The first baseball cards were printed in the late 1860s. I had no idea it was that long ago. Wow.
I thought it was in like the 19 something.
Yeah, me
Not that
too.
80s.
1860s. I bet they're worth so much money if you have one that's that old.
That'd be like $1,000.
Oh, at least. Yeah, probably more.
more.
Maybe more. Okay,
Then
the
you'd be
first
rich.
baseball cards were printed in the late 1860s. In 1933, a company in Boston was the first to put bubblegum in with the baseball cards.
Ew.
The company also printed fun facts about baseball players on the backs of cards.
Why did they put gum?
Well, it was wrapped. It was wrapped.
It must be really gum.
So have you ever bought a box of cereal and there's something in it?
Yeah.
It's like that. You would get a box of gum and there'd be a baseball card in there.
Huh.
But the gum would be wrapped so it wouldn't get on the card.
And the baseball card.
Okay, so guys, the company also printed facts about baseball players on the backs of the cards. Kyle bought 7 packs of baseball cards. Each pack has 6 cards. How many cards did Kyle buy in all? Plan. Write an equation to represent the problem. Let the square be the total number of cards. So do we know the square?
No.
No.
Do we have to?
7 times 6 equals a square.
It's
You know what
42.
I was just teaching the first graders? You can use X and Y as well, right?
Yep.
All right. Use the distributive property. 7 times 6 is the same as 7 times 3 plus 3, which is 7 times.
Something.
42.
I'm gonna get upset, Gideon. Let's do this. 7 times 6 is the same as 7 times 3 plus 3, which is the same as 7 times something plus 7 times something. It's easy. 3, thank you. Ruben's awake. 3 plus 7 times 3 again, he just said. Okay, which is, well, what's 7 times 3?
27.
No,
Oh. 21.
21.
I was thinking of 9.
You were.
I get those mixed up all the time.
Plus
Plus
21 again. Good.
equals
Which equals
42.
42.
Duh, people. Think.
Check. Use the distributive property in a different way. 7 times 6 is the same as 7 times 5 plus 1. Now this makes way more sense. Okay? 5s are easy and 1s are super easy. Okay, so which is the same as 7 times 5 plus 7 times
1.
1. Okay, which is how much for 7 times 5?
35.
Thank you, 35.
Thinking of 5.
Gideon.
Plus 35.
And then how much for 7 times 1?
7.
7.
Sinus.
Which also will come to 42, right? 35 plus 7?
I did not get that.
Well, I'm glad you said that. They're splitting the 6 two different ways. Here they said 3 plus 3. And here they're telling us to do 5 plus 1, which is actually a great idea. Because you can do 7 times 5 plus 7 times 1, which is 35 plus 7. And if you don't know 7 times 6, this is a good strategy. It is. Because everybody knows 5s and 1s. Okay, so that we got 35 for 7 times 5, plus 7 for 7 times 1. Now do you get it?
I do.
Good. Now let's do 35 plus 7. 35, 36,
42.
37, 38, 39, 40, 41, 42.
Or you could put numbers.
Same, so that's good. So the product, which is the square, is
42.
42. Kyle bought 42 cards.
Those must be expensive.
Now, Gideon obviously does know his 7s and 6s because he did say right away 42. But for a kid, yeah, you looked. For a kid that doesn't, this second strategy is a good one.
Yeah.
The first one, to me, it didn't help much. The second one,
Yeah.
let's go to page 44. Page. Okay, we've got some arrays here. Write multiplication sentences for the array. This one, and then they flipped it, so I'll get us started. This is 4 groups of 5. And we all know what that means. Now, who wants to do the second one? It's easy, it's just, it's almost the same. Yeah, Griffin,
5 times 4.
thank you. 5 times 4 equals 12. So what property?
Commutative.
Commutative. Good. That's the commutative.
Can I do the next one?
You can.
2 times 6 is 12.
Can I do the next?
Yes, Silas.
6 times 2 is 12.
Good. Again, it's that commutative property. It's my favorite property.
Because,
Well,
because you get more property from it.
Not only is it the easiest, it's the one I use the most.
And the distributive property is the oldest and the oldest to say.
Distributive.
All right, this is all. Let's go to number 3 here. It says use the commutative property, yay, my favorite one, to write another equation. Number 3. 4 times 8 equals 32. Griffin.
8 times 4 equals 32.
Let's just do a round robin and go to Ruben. Can you do number 4?
3 times 6 equals 18.
Where's the bathroom? Would Gideon do the next one?
Sure. 5 times 8 equals 42.
Thank you. I feel like you guys are getting very comfy with this property.
I love it.
Back to Griffin.
What?
Oh, sorry, Silas.
9 times 2 equals 18.
9 times 2
Can I say the 2 next?
is 18. Now, Griffin.
7 times 8 equals 50.
Thank you.
Dad,
No,
I need
not
7 times
9
8.
times 6 equals
I need 8
54.
times 7. 9 times.
You're right, Griffin.
Yeah.
Thank you.
I need
Ruben, before we do yours, he forgot to flip it, so we're going to flip it. We're
Yeah.
going to put the 8 first. 8
Damn.
times 7 equals 56.
I thought I did a lot.
Okay, Ruben, you can go.
9 times 6 equals 54. 9 times 1 equals 1. Million. Because they only.
Gideon, do you need a repair sheet?
No.
Stop all the background talk. Now we're going to go in here, fill in the missing number. 5 times 4 equals 20. Let's keep doing round robin and go to Gideon.
48. Ding.
What goes on the line?
4.
Gideon?
48.
No, we're on number 9.
Oh. I thought we were on number 4.
Good. Let's go to number 10, and it's Silas' turn.
2. 7 times 2.
7 times 2 is 14.
Can I
Now we're going to go to number 11, and it's Griffin.
8 equals
Good. Product stays the same. Okay. Number 12, that's you, Gage.
Notes. Oh.
9. Okay, good. Number 13, Ruben.
It's 7.
14, Gideon.
45.
So that was quick and fun.
Because I did it.
Because the commutative property is very easy, but it's also the one that you probably use the most. The whole point of the commutative property is to make math more efficient. So if you get a problem like 9 times 7, you can flip it because 9s are
Oh, that's 80. That's 54.
No, it's not.
62.
63.
Enough of that.
And of course, it's much quicker to get to 63 by skip counting your 9s than your 7s because 9s are pretty easy. All right, those are whereas 7s you have to think of it. Yeah, Griffin.
I just noticed something cool. So you know how 36. So if you count by 9s, 3 times 3 is 36. If you flip that around, it's 63.
Yes, and in the 9s there's a lot of weird patterns like that.
Yeah.
Yes, one, 2, 3.
Because think about it, Griffin. What is 5 times 9?
45.
Okay, what is 6 times
54.
9? Ooh, which is 45 flipped. The 9s are so cool, you guys. What is 3 times 9?
Oh. 26. 27.
27. What is 8 times 9?
72.
72.
72 is 27 flipped. So
Wow.
the 9s, if you write them and fold them in the middle, it's like looking in the mirror. The 9s are super cool.
Yeah.
There's a lot of weird patterns with them.
That's not my name.
Last page,
Okay, one more.
find the product and show how you multiply. So 15, Silas, you get to just group them. You know, obviously they want you to use the associative property, okay?
So make them all backwards.
No, I'd like you to, which ones do you want to associate closer? The 3 and the 3 or the 3 and the 2?
3 and 2.
Okay, so we're going to keep Lister, the first 3 by itself, and put the other 2 in parentheses.
Restart it. Are you ever gonna do your work? Or you're just gonna write things into
So now, Silas, what are we going to do for our next step? Do we work on this guy yet or on those guys?
The parentheses.
Good, so we're just going to leave that guy.
18.
Fish was
Now, what are we going to put for that?
fish.
We have to solve the parentheses.
3 times
Oh,
2.
this definitely says
6. Okay, so you guys need to keep the first part and then write 6. Gage, I don't see you doing that. But now, solve it.
3 times 6. 6, 12, 18.
Nice. So we'll just put our last little equals and write 18. It is Griffin's turn. Griffin, you're going to do number 16. How do you want to associate those?
Put the 5 and the 3 together.
That's what I would do. Yes. Griff, Gideon, sit up. So this time he's starting with his parentheses, unlike Silas, okay? He's putting the 5 and the 2 together. Great idea because that makes 10, and anything times 10 is...
Wait, no, I started with the parentheses.
No, you put your parentheses on the second pair of factors, not on that first one. So he's doing it a little different than you, and that's good. Now, Griffin, do we keep the times 4?
Yeah.
Yeah. Oh, I should have done that up here. You all right with that? No? Okay, I'm gonna wait. I'm just gonna sit here and wait. Or we can start the video over and start the lesson over. Or we can do, we can learn how to do this. This is the associative property. So I'm seeing about half of you not writing what I'm writing. So I'm going to count in my head to 20, and if it's not done, we'll just start over. Thank you. Now I know that some of you know the answer, but you have to allow this packet to teach you this method. Like I said, when you start working with big numbers, you'll want to know associative property. Let it teach you. Be humble. Okay? Don't be proud and be like, I got this. That's called a mastery mindset. You want to have a growth mindset. If you have a growth mindset, you will grow in your learning your whole life. Put it equals and let Griffin walk us through the next step.
5 times 2 is 10. And the 4.
And now we can solve.
14.
No, 10 times 4 is not 14. It sounds like 14.
Oh, 40.
Yep. Which is what you meant.
Yeah.
I know in your head you saw a 4 and a 0. It just came out 14.
14.
So that happens sometimes.
Yeah.
You're probably blushing.
So remember, stay humble. I want you to erase what you wrote there, Gideon. Okay, you too, Ruben. Erase that, and we're going to let Gage walk us through this. Go.
How many is 1 times
Okay, so you're gonna leave the 6 and put the 1 and the 5 together. Again, that is what I would have done. That's pretty funny.
Actually, yeah.
And then
Good. So we're gonna leave that 6 and just put a 5. Great. It's easy, right? Now solve.
6 times 5 30.
And that is what those boys had put. But let yourselves learn. Don't be afraid of this. Because you go to 4th, 5th, and 6th grade and start getting problems, Gideon, that go into like thousands,
Ooh.
and you will want to know how to do this.
Yeah.
You'll want to know how to split put the if you get 3 different factors and it's getting into hundreds and stuff, you're going to want to know how to group those. Last one, and it's back to Ruben. So Ruben, which ones are you going to associate?
2 and 3.
Okay.
That's what I would do.
Probably I would have 2.
I did the other way. Is that okay?
It's 2 times
Yeah.
3 times 8. And 2 times 3 is 6.
And then we need to keep the
The 8.
times 8.
The 8. And then 6 times 8 is 48.
Good. It is.
Yeah, I got the same answer.
Okay. So I'm noticing that we have 2 that were grouped this way and 2 that were grouped the other way. So that's pretty cool. It was a nice mix. Okay, choose the best answer. 4 times 5. Is it the same as 4 times? Uh-oh, I'm waiting for Silas. Okay, choose the best answer. 4 times 5. Is it the same as 4 times 2 times 3?
No.
Good, you guys, last year everybody said yes. They're trying to trick you. They're hoping you think that's a plus right there, and it isn't.
Yeah, it's not.
Right? That's a tricky one. Is it the same as 4 times 2 plus 3?
Yes.
Yes.
Yes. We're going to go with B. All right. Number 20. 7 times 9. Is it the same as 7 plus 4 times 5?
No.
No.
No. Not even close, right? Silas, stop distracting yourself. How about 7 times 4 times 5?
No.
How about 7 plus 4 plus 5?
Yes.
Yes. No.
No. No. No.
How about 7 times 4 plus 5?
Yes.
Yes.
Yes. Yes, it did. These are kind of sneaky, aren't
I
they?
love them.
Mhm. 21. 3 times 2 plus 2. Is it the same as 3 times 2 times 3 times 2?
Uh-oh.
No.
No, but that's a tricky one. How about 3 plus 2 times 3 plus 2? No. 3 times 2 plus 3 times 2.
Yes.
Yes.
Good. Oh my goodness, you guys are awesome. You've got your brains screwed on tight today. Last one. 5 times 2 plus 5. 5 times 2 plus 5 times 5.
Kind of no.
No.
Actually,
Yes.
Yes.
that's the one, guys.
That trick.
Yeah,
one.
Gage, you were kind of thinking about that one. Yeah, that one is tricky. Okay. I bet if I had read all the other ones, you guys would have gone back to that first one and said it was the right one, but I didn't. Then let's do the bottom 2 problems. So 23, make a drawing to show how 3 times 5 and 5 times 3 have the same product. Okay. Blobs.
Blobs.
Okay, we'll do 5 times 3. 3 times 5 is going to be 3 rows, and each of them will have 5 blobs. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And on the other one, 5 rows, each one with 3 blobs. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. Oh my God, I love that problem. So last one, write a real world problem with the equation 2 times 2 times 3 equals 12. So whenever they want you to write a real world problem with times is, you want to think groups, and the best way to group stuff is in baskets or bags, or, think about how you would group it.
How about Gatorade?
No, please don't do Gatorade. I don't want to hear about Gatorade. All right? Ever since my first year teaching here,
Coke.
Jacob.
Coke box.
Coke. You read my mind.
Well,
Gatorade.
Griffin.
can they be crates?
Sure.
Can they be cannibal?
3 crates of corgis.
Oh. The crates of corgis. Okay.
How
So
big are those?
How many corgis in each crate?
Um,
You gotta look at the
2
numbers.
in each
2 in each
crate.
crate. Now each corgi has
5 hamburgers.
5 hamburgers.
2
ears. How many ears total? Okay. Love it. 3 crates. Comma. 2 corgis in each crate. I thought you were going to say each one had 2 chew toys.
So did I thought you were gonna say hamburgers.
And he just went with the ears, and that's easier. Because it's a lot easier to write ears than chew toys. Comma, and each corgi yes, I'm afraid so. Has 2 ears. And then, of course, we do have to ask how many what? Ears. Yes. How many ears? What a funny problem. This is probably one of the funniest ones I've ever done.
It's because corgis are
All
my
about
favorite
corgi
dog.
ears. Hey, I love corgis too. And their ears are adorable.
I'm not even
You guys know, corgis are one of the cutest dogs. They're just adorable.
Like my corgi.
You have a corgi too?
Yeah, he does.
The
Oh,
one I brought for Sterling.
he's part corgi.
That's why he has the short tail. And long ears.
And he's smart. They're super smart.
And once you bite
Our corgi is dumb. He runs at, he chases our cat, he scratches him, he goes back for more.
Oh, yeah, that's pretty dumb.
And he runs away.
My dog,
He comes
when we're at my mom's classroom, which is about a couple streets away, my dog can follow us. And we have no trace. He can just walk there. And we weren't. And it takes. It was like.
And then find his way home.
If I had it, he could walk to our classroom and he scratches on the door to get us.
If I had a corgi, I would sniff it out and sniff its butt.
Every dog does that.
Actually, your corgi Wyatt has a long tail is because